chemical reactions we've seen are like recipes. They tell you what proportions that you need to mix reactants and products together in order that you're not wasting any ingredients. Now, often we want to know how to relate grams of a reactant with grams of a product. For example, your metabolism is based on burning glucose, which is a sugar. It's got this formula. And that combines with oxygen gas to give you carbon dioxide and water. And we often want to know something like, if I have 1 gram of glucose, how many grams of carbon dioxide are produced? Or how many grams of O2 do I need to completely burn that up? Let's figure out how many grams of oxygen gas I would need to have to burn up 1 gram of glucose. Now, the first thing you should notice about my roadmap here is that I'm starting with one substance and I'm ending up with another substance. And what do I need? Anytime I'm changing from one substance to another from the last video, the point of the last video was you need a mole-to-mole ratio that relates these two. And where do you get it? You get it from a balanced chemical equation. I've got a chemical equation up here, but it's not balanced. So let's balance it. I put a 1 in front of the most complicated, ugly-looking thing in the equation and see where that takes me. If I put a 1 in front of this, it means I have 6 carbons on the left-hand side. So I have 6 on this side, too. If I put a 1 in front of this, it means I have 12 hydrogens on the left-hand side. So to get 12 on this side, I'll have to put 6 there. Now I've got the right-hand side of the equation nailed down, and I can count how many oxygens I need. So there's 6 times 2 is 12, plus 6 more. So 12 plus 6 more is 18. So I need 18 oxygens on this side. Now, I've already got 6 there. So I need to have 12 here. So to get 12 here, I'll have to put a 6 there to balance this off. So now this equation is balanced. And I can get a mole-to-mole ratio between the two things I'm interested in. I'm interested in glucose and I'm interested in oxygen. So this equation tells me 1 mole of glucose reacts with 6 moles of oxygen gas to give me, let's write it down first. So that's going to be in there. That's going to be the critical link in this problem. But I've got grams here. So I'm not going from moles to moles. I'm going from grams to grams. But what I can do is go from grams of this to moles of this. To moles of O2 to grams of O2. So this link that I have here helps me do this critical link is right in the middle. I'll drop it into the middle of my roadmap. And I'll drop the moles of oxygen close to the grams of oxygen because I know what to do there. Whenever I'm relating a mass to moles, what do I need? A molar mass. I need the molar mass of the O2. Now, 1 oxygen weighs 16, so O2 is going to have a 32 gram molar mass. So that's the link I need to do this step. How about this step? I need to go from grams of glucose to moles of glucose. So I need a molar mass there too. So let's see, 6 times 12, 72, plus 12, plus 6 times 16 is 180. That's the molar mass of this. That's the link that I need right there. So now I have this 3-step procedure to go from grams of this to grams of that. Let's do it. I'm going to write down my starting point again in my roadmap. Now I'm going to turn each of these links into a conversion factor. I need to have grams of C6H12O6 on the bottom. And here I have got 180.16 sitting next to that, and on the other side I have 1 mole. The grams cancels out, and if I stopped here I'd have moles of C6H12O6, but that isn't what I want. So I have to keep going, and I want to get rid of moles of C6H12O6 here. And I'm at this point right here in my roadmap. I want to go here. There's a link between 1 mole of C6H12O6 and 6 moles of O2. That gets rid of moles of C6H12O6. Now I've got moles of O2, but that isn't where I'm trying to go. I'm trying to go to grams of O2. So I have to do one more step where I get rid of moles of O2. And here's the link that I need. 1 mole of O2 is 32.0 grams of O2. So I pick my calculator at this point. 1 divided by 180 times 6 times 32 is going to give me the answer, whatever that is. All right. Now let's look at well, how many significant figures are you going to have? If this has 3 significant figures, this has 5, this has 3, this is exact. I'm going to round off whatever answer I get over here to about 3 significant figures. All right. Okay, so let's step back and look at the general pattern that we have here. Whenever I'm trying to go from grams of one substance, let's call it substance A, to grams of another substance, let's call it substance B, I have to drop a mole-to-mole ratio in the center. So your flow is going to go like this. You're always going to be going grams to moles for the first substance, moles of the first substance to moles of the second substance, and then moles of that to grams. Here you're going to need the molar mass of A. Here you're going to need the molar mass of B. And here you're going to need the mole ratio from the balanced equation. All right?